The M3 kit is a dial gauge calibrator which is delivered with a Silvac measuring system, high accuracy probe, which is connected on a digital unit. This dial gauge calibrator has ceramic gauge blocks here that make the transition between the probe, the master, and the instrument to be calibrated. You can calibrate either a standard dial gauges, so standard with a digital output, but also old analog dial gauges, and even on the stand having here an accessory, you can make the calibration of the lever indicators. Now here, this calibrator is working manually, so non-motorized version. And here, with this wheel, we will displace the probe and the gauge blocks, having a slow or quick movement. Everything is linked through this unit to a software. This software is called Seco Pro, which is also inclusive with the M3 kit. This Seco Pro software allows you to make the report and the certificates for all dial gauges mentioned that you add on the M3 kit. But you can also, with the help of the gauge blocks, calibrate some micrometers, some calipers, and other kind of instruments. For the calipers, for example, you can make for only one instrument the reporting of the external jaws, internal jaws, and depth gauge, for example, in different sequences, which can be very useful for the calibration of the entire range of measuring equipment. So here for the use of the M3 kit, it can be used on different software, but here it is delivered with the software called Seco Pro, and this Seco Pro makes the link between the dial gauge and the M3 kit if you have a data output. On this software, you can define a group of instruments. So this means a different kind of dial gauges using different standards, digital calipers, mechanical indicators. Whatever you want to do, you can create a group. Here in this group, I have created a demo group in order to do this small movie. And here you can define all the gauges. So on the gauges, you have here the three different gauges. Here I have also made a new gauge called Demo S-Dial Work. And this Demo S-Dial Work, you can enter the brand name of the gauge, the measuring range, a pre-travel if needed, if the gauge you want to check has or not a digital output, or if, for example, it is a mechanical gauge. You can put the resolution, millimeter or inch, whatever you want. And as well, you can enter here the norm that you need to use for this specific instrument. This means that this norm here can be created as well and be used for all that kind of instrument. It will automatically connect with this norm. Now here we have the norm, the standards. The standards as well can be defined in a list. We delivered the software with the main and most well-known norms that we have here. but sometimes you will need to make your own norm and to correspond to your own specific standards. So first of all, you will have to define the linear on the entire measuring range of the gauge, or you want to make the measurement. So for example, going in, out, or in and out. Okay, here specifically I just make one way. If I want to take many measurements to do the average, what would be the permissible errors? So the deviation, here you can see directly what is corresponding to what. So here, for example, the span error, the deviation on curve, the deviation on two consecutive measures, and the total deviation. Here, the inspection step has to be defined. So I could enter either an inspection step of 1 millimeter, for example. Then it will take a step every millimeter all along the gauge measuring range. Or here I can predefine some measurements. So for example, here at 2 millimeter, 5 millimeter, 10 millimeter, yeah, and that's it. Then once I have done this the step inspection, then I will have to go for the local error. This local error will be also defined in the maximum deviation position, or minimum, or algebraic deviation. So this will make the position between in between the curve, or directly on the predefined position. I could put here 5 millimeter, for example, and take these steps on this point, and there it will create the three or more, whatever I want, number of steps for the local error. Then here, once again, I can define the permissible error for this, and also for the hysteresis. Now, we will have to look for the repeatability. So once again, the repeatability, you can define the method of calculation of the repeatability. How many value measurements you want to take to define this repeatability. And here, if you want just only go in, out, or both, and in which position you want to make it. This repeatability, you can also predefine different step wherever you want to take different points for the repeatability. And now I can just put the printing option for this norm, and here say exactly what I want to show on the graphic, and that's it. Now, for example, for a caliper, I could add some sequences. So here, this sequence, if I put more or less sequences, if I put one more, here this norm can be done for the external jaws, internal jaws, depth gauge, for example. That would be a possibility of this software. This software, the master can be the probe of the M3 kit, but also could be for a caliper. If we take a caliper like this, the master can be gauge blocks. Then here, once we have created our instrument, once we have the norm that we need to use in the software, we will be able to do to start the measurement. For this small movie here, I will show you how to make a measurement for just only for dial gauges with digital output. So here, Once I have chosen my gauge in the group that I have made before, taking the standard I wanted to use, I will go and put here, come with the gauge blocks and just touch the dial gauges. Once I have touched the dial gauges, I can make a preset, and this will zero my gauge, but also the master unit. Then here we can start the measurement, enter a serial number, and go here up to the predefined points I have put. Here you can see I have put 2, 5, and 10 millimeter steps, but it had the 0.1 value of the pre-travel, which is also due to the gauge, which I have entered, creating my gauge. Here then, with the wheel, I will go up to this point of 2.1 millimeter. As it is having the digital output, no need to be exactly at the right point, because it will make the concordance between both units. So here, if I'm a little bit away from the specific point, it will correct onto this unit. On the mechanical gauge, here you will have to be very accurate. So then you can use the very slow and precise movement with this second gear. Then, once I have my step, I can send to the gauge, to the computer, which will tell me the next point to reach. So I go here to 5.1 millimeter. I go after to 10.1 millimeter, and here we are finished with the steps for the total range error of the gauge. Now we do the local error. This local error once again is defined as per my norm. So he asked me to go at this value, 4 millimeter 109. Then 5110. Then 6112. Then 7113. And we are finished with the local error. We will continue then on the repeatability. For repeatability, he asks us to go on 5 millimeter. Okay. And we take the different step for the repeatability. And now here we are finished with the measurement of this equipment. Automatically, in the end of the measurement, the measurement and the certificate is saved in the format that you need to have, and you can recall those different measurements afterwards that you can find in the measurements to the different standards. So here, for example, my demo S-dial work, that is my old measurement, and I can have a look on this predefined format, having the different field here that I can display as I want with the information which are needed. The configuration, you can do it here with the logo, with the different fields, what you need to show or not, all of this can be set. Then here, as well in the option general, you can save a txt file the measurement. You can have automatically a copy of the different group and name of instrument in the Seeker Pro, and you can generate a PDF automatically or XLS file. This XLS file or PDF can be stored and saved directly on the server of the company and a centralized server, which is done in Silvac, for example, on the different plants that we have. I think it's all what I can say at the moment, and I remain at your disposal for further information.